Hello to everyone who is interested in cloud-native technologies. This lab will be of interest to you if you are seeking of a way to utilize OIDC authentication in GCP to access cloud resources from a GitHub Action workflow securely without the need to expose sensitive data such as credential or token. To begin, we will navigate to the GitHub and access the repository containing the lab code. To keep the code easily accessible, we will create a fork of the repository under the desired owner. I will use my personal account as the destination. The next step involves cloning the repository and opening it in a convenient manner. In this lab, I use the Visual Studio Code. Excellent. The code was saved on my local computer and we can proceed to open it in the Code Explorer. If you encountered a pop-up window prompting you to open the repository in the development container, click the Open in the Container button to accept it. Otherwise, you will have to manually select this option in the lower left corner. The README file at the root of the repository serves as our cheat sheet for all the commands we need to execute. You can reproduce the lab by following the procedure outlined in the README file. Before we dive into the process of entering command and validating the configuration, let's briefly discuss the components that make up the entirety of this challenge. The main configuration is stored within the main TF file. As you can observe, there are only 5 essential resources needed for OIDC configuration here. First and foremost, there is the service account, and the second requirement is to ensure that the IAM credential service is operational. The third and fourth components closely interrelated, and the identity pool and the corresponding identity pool provider. However, it's important to note that you can configure multiple providers for the pool, such as AWS or SAML. Lastly, the resources that establish a connection between the service account and the identity pool is the service account IAM member. At this stage, the OIDC configuration is defined, but it may not be demonstrable as the service account lacked permissions for GCP resources. That's why there is another Terraform file, IAM roles TF, in which we grant the service account the necessary permissions to retrieve a list of projects in the account. It's the role browser and be able to get list of the storage buckets. And we will start from getting authentication for the application default. Run this command will generate an exceptionally long URI, which we can then pass into the browser to obtain the secret answer required to complete the authentication process. If you wish to initiate a new project for this lab or create a fresh storage bucket for storing Terraform state file, it requires to be authenticated as a generic user in advance. In this lab, I've desired to demonstrate the most complex scenario, which entails creating both a new project and a new bucket. That's why the follow command should be executed. And we will follow the same procedure as you already seen in the previous step. The next command involves defining an environment variable where we will specify the project ID we want to use. Next, we create the project, and it's important to link this project to a billing account. I've included in this command the automatic retrieval of the active billing account you already possess, so there is no need to search for it. The follow command defines an environment variable that will store the name of the storage bucket used by Terraform to store the state file. The next two commands will create the new storage bucket and apply additional security measures to prevent it from being accessed over the internet. At this step, we specify the name of the repository owner in the GitHub account that we have chosen to use. We are narrowing the configuration deployment process. To proceed further, we must change the directory to the Terraform folder. Now we need to initialize Terraform with an additional argument which involves configuring the backend. Finally, we execute Terraform apply command and can view the list of resources that will be created in GCP. After applying the configuration and before processing to validation step, we need to obtain a list of the projects to retrieve two crucial parameters, project ID and project number, that we will need as an input for the GitHub Actions. The validation process is evidently relies on the GitHub Action workflows. To begin, we should navigate to the GitHub Action tab, confirm the prompt from GitHub that indicates this repository was forked, and then proceed to access the sole required workflow, which is GCP OIDC authentication validation. This workflow was intentionally designed to be triggered manually using the workflow dispatch feature. This implies that to execute this workflow, we must click Run Workflow and provide the required input parameters, which in this case are the project ID and project number. In a moment, we can refresh the page and observe the running workflow process. Once the workflow is completed, you can expand the steps to view the more detailed information about the processes that occurred under the hood. The most curious steps include authenticate to Google Cloud. There you can review all the parameters. Then the step is marked as successful green. It indicates that the authentication was successful. Additionally, the gcloud storage ls step has been intentionally integrated into the workflow to demonstrate how permissions assignment works for the service account used by the OIDC authenticator. Within the steps output, you can observe the list of the existing storage buckets in the project. And this is the end of the lab. I appreciate your interest and eagerness to acquire new knowledge. I'm grateful for your attention. Bye.